This video is about chain and branch naming organic compounds. I sometimes call the chain a bracelet and the branch a charm. So this is a common looking organic compound. And if you look at the compound, you will see that this particular one is a compound of hexane because it has 1, 2, 3, 4, 5, 6, that's hex, carbons, and all of the carbons are single bonded, and that kind of bond is called alkane, and we put that together and we say hexane. So this compound is a hexane. When you are naming a carbon compound that has branches off of it, the first thing you have to do is look for the longest continuous run of carbons. So the reason I call it bracelets and charms is because this would be the longest continuous run, and to me it kind of looks like a bracelet with this part hanging off looking like a charm. So we'll talk about how to name this carbon compound and many other carbon compounds like it. To name this carbon compound, you first have to know how many carbons you have in your longest chain, and that is the last name of the compound. I kind of think of it like first name and then last name, and your most important name is your last name. So the main chain is your last name. So the last name of this compound, 1, 2, 3, 4, 5, 6 is hex, and they're all single bonds. So the last name of this is hexane. Now you have to say where this charm or branch is coming off of your chain, and I numbered it from left to right, and by coincidence it is from left to right on this one for you, but in naming sometimes you have to number the other direction to see which way is the smallest number. If I would have numbered this way, 1, 2, 3, 4 would be where the charm was hanging off, and 3 is smaller, and it always goes by the smaller number. So you have to say where something is hanging off of it, and then you have to say how many carbons are in that chain, in the charm, and this is the chain. And there's only one, so that's meth. And because it is a charm and not a chain, we let the reader know that by adding YL. So this is a 3-methyl hexane. Okay, you noticed I said methyl, and that is because whenever you are naming a charm, you add YL to the end of the organic prefix. Since you are counting carbons, you are still using the meth, F, prop, bute, and as always for 5, pent, 6, hex, 7, hept, 8, oct, 9, none, and 10, dec, and we just add the like a little sound at the end. So methyl, ethyl, propyl, etc. So 1, 2, 3, 4, 5, 6. So that is the longest continuous run of C's, as opposed to 1, 2, 3, 4, or 1, 2, 3, 4, 5. 6 is the longest one. And then how many carbon atoms are in the charm? Just one. That's where the meth is coming from. So since it is charm, it ends in YL, so methyl. And since the backbone has 6 carbons, it's hex. and because they're all single bonds, it's hexane. So the whole entire name would be 3-methylhexane. All right, so first order of business, find the longest continuous run. And sometimes this takes counting multiple times. So when you are counting, you just 1, 2, 3, 4, 5, 6, 7, 8. If I counted straight across, I'd get 8. If I started down here, 1, 2, 3, 4, 5, 6, 7. If I started here, went up and over and down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's more. And then as you can see, if I start there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so 10 is my longest continuous run of C's. So the last name to this particular compound is decane. Dec, because of 10. And then these are all single bonds here. That's just a single bond. So decane, A-N-E. Then you have to say what you have hanging off of your main chain. I've got a charm here, and I've got a charm here. This one is methyl, because it's just one carbon. This one is ethyl, because it's 2 carbons. Now you have to tell the reader where those charms are at. And in doing so, you have to count where you get the lowest score. And you're counting where these connections are. So if I count starting here, 1, 2, 3, they are at 4 and 7. And if I count going this direction, 1, 2, 3, they'd be at 5 and 8. Because 4 and 7 equal less than 5 plus 8, we're using the 4 and the 7. So we're not going to use the 5 and the 8. We just counted because we have to be sure we picked the right direction to do that. So we are going to be using the numbers 4 and the number 7. So which thing gets listed first in the first thing? The ethyl is at 4 and the methyl is at 7. The number has no bearing on the order in which you name. They are solely ordered by their alphabet. So this would be a 4 ethyl, and then 7 methyl, and then the last name of decane. So 4 ethyl, 7 methyl, decane. So let's give this one a try. So they've already showed you the longest continuous run of C's. And now you have to decide numbering. So is it 1, 2, 3, 4, 5? Or is it 1, 2, 3, 4, 5, 6? Because 2 plus 5 is less than 6 plus 3. The 2 plus 5 way wins. So that means this is carbon number 1. This is carbon number 2. This is carbon number 3, 4, 5, 6, and 7. So there are 7 carbons in my main chain. 7 carbons that are all single bonds. So if you have 7 carbons with single bonds, you have a heptane. So my last name is heptane. Now what's my first name? My first name is based on these charms. So I have a charm here at 2 and a charm here at 5. They're both the same kind of charm. It's a 1 carbon charm. So you have 2 of them. So you have a methyl charm here. It's technically a 5-methyl. And we also have a methyl charm over here. And that is a 2-methyl. And so since I have 2 of them, I say the numbers 2 and 5, 2, 5. And then I have to tell the reader I have 2 methyls. So I say dimethyl. So my first name is a 2,5-dimethyl. And then my last name, as we said before, is heptane. So I'm a 2,5-dimethyl heptane. Try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My last name is Deck. And because I have this double bond right here, I am an ene. Also, this double bond is letting me know that this is carbon number 1. Because just like charms, who's ever closest to the double bond in numbering, the lowest number is carbon number 1. So when you have already set the numbering system for numbering the double bond, then that's what the numbers are for your charms. So I have a 4-methyl, but before that I have a 7-ethyl. Why did I put the ethyl before the methyl? Because it is E as opposed to M. And then my last name, where is the double bond? It's on 1. So it's a 1, and then Deck because of 10, and then ene because of the double bond that's right there. So my full name is 7-ethyl, 4-methyl, 1-deckene. All right, this is like the worksheet that's called the beginner's worksheet, and the only difference is they put all the hydrogens in there for you. So the first step, once again, is to find your longest continuous run. So we're going to say that is, just for fun. We could have said it was straight. It's the exact same number, but we'll just add some variety to the order of our thing. So I've got 1, 2, 3, 4, 5 carbons. So my last name is going to be Pent, and because these are all single bonds holding them together, pentane. Now we have to say where this is hanging off, and I realize I just numbered 1, 2, 3, 4, 5. I was just counting carbons. We actually will end up numbering this direction, because that puts it, if I numbered the way I said before, my charm would be at 4. And if I start and number this direction, my charm is at 2. And we always number it to where the numbers are the lowest. So this is a 2-methyl pentane. So 2-methyl pentane. Let's try it again. Longest continuous run of C's. This time we'll go this way. And we've got this guy hanging off. You count 1, 2, 3, or if I count 1, 2, 3, either way, I'm on carbon number 3, so it doesn't matter which way. but I have 1, 2, 3, 4, 5. So once again, I'm a pentane, and the thing sticking off of me at number 3 is a 3-methyl. So I'm a 3-methyl pentane. Last one is organic worksheet number 2, the sticks worksheet. It's exactly the same, except you don't get to see the carbons. It is find the longest continuous run. So 1, 2, 3, 4. I'll highlight that with the pen instead. It was kind of hard to see. So 1, 2, each end of this. 1, 2, 3, 4. That's my longest continuous run of C's. 1, 2, 3, 4. So my last name is butane, because they're all single bonds in this diagram. And then you have to say where you have things sticking off. So these are dead in the middle, so it doesn't matter which way you count. So 1, 2, 3, 4. Since these are just straight sticks here, that means there's just a methyl here. So I've got a methyl there, and I've got a methyl there, and I have a methyl there, and I have a methyl there. So where are they at? They're at 2, 2, 3, and 3. And how many methyls do I have? 4. So we say that tetra, T-E-T-R-A, tetra methyl, because I'm counting the methyls, not counting carbons, so I don't use the carbon prefixes. So it is 2, 2, 3, 3, tetramethyl, and then my last name was butane. All right. So go ahead and get to work.